Hi guys, Mr. Rocco. Hope you're having a good weekend. This is going to be the last week of astronomy, and then next week you'll have another quiz, astronomy quiz number 2. Also remember that the 5-week period, the halfway point of the second quarter, ends this Friday, which is December 18th. So please make sure if you have any ode work, any labs, anything you're missing, check Canvas. Check your grades, look for zeros, and get those assignments in ASAP. Okay, this video is going to be about 3 things. Phase of the moon, the tides, and eclipses. So let's start with phase of the moon. Phases of the moon are the illuminated portion of the moon that we see, right? If you look up at the moon at night or even daytime, you'll see sometimes you can see a crescent moon, sometimes you see half the moon, sometimes you see a full moon, sometimes you don't see any moon. So that's the phases. It is cyclic, which if you remember that word, that means it repeats, right? This number you have to know. This is another number, important in earth science. They'll ask this question: how many days does it take to go through the phases? And the way I remember that, if you take the letter P in phases and you flip that horizontally, like mirror image, flip it backwards, a P backwards makes a 9. That's where that 9 is going to come in. So it takes 29 and a half days. 29 and a half days to go through the phases. The Regents used to allow students to say a month, like you could say 1 month, which is almost. But now they're being a little bit more nitpicky, and they want you to know that exact number. So it takes 29.5 days to go through the phases. So just remember, in the word phases, if you take that P, and that'll flip that backwards, it makes a 9. That'll help you to remember it's 29. What causes the phases? 2 things. The Earth is rotating, right? We rotate. And the moon is revolving around us. So it's the revolution of the moon, and it's the rotation of the Earth that creates the phases. Now, you might say, well, let's look at this 29 and a half again. Why worry about the 9? The moon actually gets around the Earth quicker than 29 and a half days. And this is in your ESRT. If you go to your reference table on page 15, they list the data for the moon at the bottom. How far the moon is from the Earth, how far it is from the sun, and then these 2 numbers right here. Oops. Period of revolution, period of rotation. So it takes the moon 27.3 days to make a revolution. That means it takes 27.3 days for the moon to get around the Earth. But if you go back to that last slide, it took 29 and a half days to see the phases. And that's why that little trick about flipping the P backwards to make a 9 is going to help. Because students will confuse 27.3 and 29.5, and they'll say, oh, which one is for the revolution, which one is for the phases? The revolution number you don't have to memorize, right? It's in the reference table. So here it is. So if they ask a question on the Regents, how many days does it take the moon to actually make 1 revolution? It's 27.3. If they say how many days again to go through the phases, that's where you want that P, flip it backwards, and it makes a 9, so that you don't confuse the 27 with the 29. Now, you'll also notice, and we'll talk about this here, the time it takes the moon to make a revolution, 27.3 days to get around the Earth, make a revolution, is the same exact number as it takes the moon to rotate. So the moon does rotate on its axis, right? We need 24 hours almost, 23 hours, 56 minutes, and 4 seconds. The moon takes the same amount of time to rotate as it does to revolve. The numbers are equal. Why? That is because the gravitational pull of the Earth, right? The Earth kind of holds on to the moon, is keeping the moon in what they call a tidal lock or a gravitational lock. It's locked in. So even though it is rotating, it's doing it at the same speed that it's revolving, which creates a special situation. We always see one side of the moon. So here's revolution. It takes 27.3 days for the moon to make a trip, one revolution around the Earth. The moon does not go around the Earth on a flat plane. So like if this is the Earth, it's not going around on the same plane. It's on about a 5-degree tilt. 5-degree tilt, which is why eclipses don't happen all the time, because everything is at different angles. It's all about math. It's all about geometry. It's all about angles. And in order to have a lunar eclipse or a solar eclipse, everything has to be aligned perfectly. Well, because the moon is going around at a 5-degree tilt, you don't get that perfect alignment all the time. And that's why you don't have lunar eclipses every month or solar eclipses every year. So anyway, it takes 27.3 days to revolve, and again, I'll go back to this slide. It takes 27.3 days for the moon to rotate. And again, they're locked into each other, which means we always see the same side of the moon. We don't see the other side because the moon is at that same rate. It's rotating and revolving at the same number, and therefore we never see the other side of the moon. This is the other side of the moon. Now, if you look at a poster, and in my classroom, I have a poster on the brick wall. It shows you the moon. That's the side of the moon we see. The poster, you'll notice if you look at that poster, you won't see this picture. You're only going to see that other side. And if you've looked at the moon in the sky, you'll see there are a few craters there, a few dark areas, some highland areas where it's kind of whitish. But you don't see this, especially this large crater here. This is on the other side of the moon. These pictures were taken by satellites and spacecraft as they've gone into further parts of the solar system, right? So as they leave Earth and go past the moon, and then they start heading out to Jupiter and Saturn, Uranus, Neptune, Pluto, etc., they turn around, they take pictures of the other side of the moon as they're going out and send that information back to NASA. And so this is the side of the moon that we never see. So you're never going to see this side of the moon outside, live, looking up in the sky. You could see this really large crater here. A little bit of background, quick history on this guy. They think, astronomers think, that at one time there was a very large asteroid, bigger than the one that wiped out the dinosaurs. They think it was heading toward Earth, and the moon protected us. The moon was our shield. It was in the right place at the right time, and notice it took the impact, and the moon protected us. Had the moon not been in the right place at the right time when that asteroid was heading toward Earth, they believe that it would have hit the Earth and done a lot more damage than the dinosaur asteroid did. So yeah, the moon's protected us quite a bit. You'll also notice you can see all the impacts on the moon on both sides. You don't see them as much on the Earth. Well, again, why? The moon doesn't have water, enough water. There's small traces, but enough water to cause erosion and weathering, and there's very little atmosphere to cause weathering and erosion too. Weathering, erosion, and water, those are powerful forces on Earth that wipes out a lot of our history, especially rock history. And so without that on the moon, you're left with the evidence, see? But on Earth, you don't see that evidence. It's been erased. Okay, so why the difference? And this hopefully will show you why. I'll try to explain it to you. You got three pictures here. So you've got A, B, C. Start with A. In order to have a full moon, everything has to be in a straight line. You have to have the sun, so sunlight's coming from this lower part of the picture, Earth, moon. Notice they're all in, I'll use my straight line tool, all in a straight line like that. That is our full moon. Sun, Earth, moon, straight line. The Earth is now going to make a revolution, right? And again, that number is over here. It takes 27.3 days to revolve. That's from A to B. So you can see on this timeline, I highlighted it in red. So for the moon to make one trip, notice where the moon is in this circle over here on A. It's just just to the right at top dead center. It's going to go around the Earth one time and end up at position B. Don't look at C yet. Just look at B. So notice where the moon is. Again, this is the top of that circle, and the moon, again, if you notice this one compared to this one, same. It's in the same spot. So the moon made one trip in 27.3 days. However, everything's moving. While the moon made a revolution, what did we do? What did the Earth do? We moved in our orbit, right? We moved from here to here. And so, let me clear this mess. If I draw a straight line, where's my straight line tool? There we go. Position B, Sun, Earth, Moon. And I say, wait a minute, question mark. The moon's not in the right spot. It's not there. It has to be there to form a full moon. See over here, go back to position A. Everything was in a straight line to make a full moon. Well, as the moon went around, we also moved a little bit in our orbit. And in 27.3 days, we don't have a straight line yet. Everything is not lined up, Sun, Earth, Moon. So if the moon could talk, it would say, time out, time out, time out. Give me about 2 extra days. The moon needs a little bit more, a couple more days, 2 extra, to put myself in a straight line. And I'll use my straight line tool again. Now I look at position C. I've got 1, 2, 3. Notice how they're lined up again. So position C is the same as position A. But that didn't take 27.3 days because here everything wasn't lined up. I needed 2 extra days. Notice the blue timeline. I needed 29.5. That's why you have a difference. So the moon goes around us, but we also moved in our orbit a little bit, and everything wasn't lined up at position B. The moon needed 2 more days to put itself in the position to get itself into a straight line again to create that next full moon. And that's why there's a difference between how long it takes the moon to make a trip and how long it takes to go through the cycle, the moon cycle. 2 extra days. 2.2 to be exact. So hopefully that picture makes sense. All right, now let's get into the phases. So if you recall in when we did seasons, and for some of you that don't come into school, the Earth and the moon are always illuminated 50-50. And that line is straight down the middle, straight up and down. So vertically. And that line, they call that the day-night line, or your sunrise-sunset line. The moon and the Earth are both illuminated half. Obviously, the half that's facing the sun is the side that's illuminated. Because of that, and because of, again, the revolution of the moon going around the Earth and our rotation, that creates the phase. It's all about angles. So let's go to this diagram. And this is the blank diagram, and then I'll show you on the next slide how we come up with the phases. So we have our 8 phases. This side on the right is what the sky view, what the moon's going to look like in the sky and when you're looking up at it, starting with the new moon and going back again. This side is a top view, looking down at the moon as it revolves around the sun. So you'll see now when I go to the next slide, I've shaded them in. So remember, it's 50-50. So here's the Earth in the middle. The Earth is going to rotate counterclockwise. The moon's going to be going around, revolving around the Earth counterclockwise. So everything going in a counterclockwise motion. Position 1 is always between the sun and the Earth. So when the moon is in between us and the sun, that is the first phase of the moon cycle. There's a trick I use, and I think this will help you. I use the letter T, but not a lowercase t. It's got to be a capital T. If you remember capital T, that is your trick. Easy to remember because the word trick starts with T, right? So if you think of the word trick starts with a T and make it capital, this T is going to hopefully, after I'm done explaining it, make it a lot easier to understand the phase of the moon. Let's see. Start with position 1. I'm going to draw my T. You have to give me a minute here. I'll use my straight line tool just to make sure my lines are nice and straight. How do you draw the T? The T is going to be sideways. You're going to go from the center of the moon to the center of the Earth. That's the base of the T. Then you're going to draw the top of the T, the crossbar, going this way. Okay. Do you see the T? It's sideways, but there's the letter T, capital T. Why does that help you? Remember, you're here. I'll put an X. You're always on the Earth. You're always letter X, looking at these 8 positions. So you're looking that way. You always see, when you're looking at this T, you only see, I'll kind of do this, underneath the crossbar. This is the crossbar. That's the part that you see underneath. Which means, here's the T sideways. You don't see anything above the T. So what I always tell kids, just kind of scribble this part of the moon out. You don't see it. If you're on the Earth looking at the moon, notice, what do you see? You don't see any illuminated portion of the moon at position 1. So in the sky, right, we're going to shade this whole thing in. Ooh, let's not use red. We're going to color this all in. And what is that phase called? That's the beginning of the cycle. And hopefully you said new moon. So there's your new moon phase, position 1, beginning of the cycle. Now you're just going to keep making the T. If you remember that capital T, you can't go wrong. That's your trick, T for trick. So let's go to position 2, going around a little bit. So now as the moon moves a little bit, the T is going to start to pivot. So you're going to go from center of the moon to the center of the Earth, and then the T is going to look like that. You got to make sure, and this is really important, that when you draw that T, that you make a right angle in here. See, that's a right angle? Make sure you make a right angle there. It's got to be a perfect right angle. Otherwise, the T trick doesn't work. Again, you only see underneath the T, the crossbar. So I tell kids right away, anything above this T, that's above it, right? Cross it out. You're looking at this portion right here. Now, 2, 3, 4, these lower positions are always the tricky ones. This is that stage effect. If you remember Coriolis effect, I said curve to the right when it comes from the north. Curving to the right looks like it goes to the left. Same idea here. Remember, you're on Earth looking at the moon that way. You see this part of the moon. You have a little tiny sliver of illuminated. The little tiny lit portion is going to make a little tiny crescent. But kids will make the mistake, say, "Oh, Mr. Rocco, that crescent is on the left." But remember, you're on the Earth looking that way. So actually, you have to flip that around and imagine yourself here on Earth looking toward the moon. That little sliver of illuminated wouldn't be on your left. That would be on your right. So I'm going to go over here now to the sky view. Oops, that's not what I wanted. I'm going to grab that box away. And that's what you would see. You would see this little crescent, but notice it's on the right-hand side. Even though this looks like left over here, you're on the Earth, remember, looking toward the moon in the sky. So that's the waxing crescent, it's called. And you might remember that from middle school. Waxing means it's growing, and then the term when it's getting smaller is waning. So right now it's in the waxing phase. So it's waxing crescent. Let's go to position 3. So again, I do center to center. Use my straight line tool. Center to center. And then I draw the crossbar. Looks like that. Make sure it's a nice, perfect right angle there. Again, anything above the crossbar, I don't see. So I don't see any of that. Again, I'm looking at the moon from the Earth. So I'm looking that way. I get half the moon. But again, it looks like it's on my left, but it's not on the left, right? It's on the right-hand side. So when I look in the sky, I see that. I see the right half of the moon is illuminated. Now, the moon has made, notice on its journey around the Earth, it's gone about a quarter of the way. Yes, one quarter, 25% of the way around on its trip, and that's why it's called the quarter moon. It's made a quarter of its trip, and it's called the first quarter because that's what it's done. The moon has just completed its first quarter of its trip. So it's called the first quarter, or you could also call it the waxing quarter. Depends on the calendar. Some of you might have a calendar at home that has the phases. So it's called waxing quarter, first quarter. Either way. Let's go to position 4. I'm just going to keep on going. So I do my T, center to center. And then I draw the crossbar, making sure it's at a nice right angle. And again, I cross out the part above the T, so I don't see any of this. Now I'm looking again, it's opposite direction. I see a little tiny sliver of darkness still. That darkness, even though it looks like it's on the right, would be on my left. But most of the moon, with the exception of that little left-hand shading, is illuminated. So in the sky, it's going to look like that. Little tiny shade on the left. That's called the gibbous, which means almost full. Just about. Waxing gibbous. Position 5. That's an easy one. I go center to center. I draw the T. I'm doing this without the straight line this time. A little quicker. So again, I don't see anything above the crossbar on the T. Notice I see the entire illuminated portion, and there is my full moon. Right? Which makes sense on the opposite side of new moon. So I had new moon, my waxing crescent, waxing quarter, waxing gibbous, full moon. So now we're going to go backwards and in reverse. So we take these phases and just reverse them. So basically, what does that mean? 4 becomes 6, 3 becomes 7, 2 becomes 8. We work our way back to the new moon. But again, I use the T. So let me just clear all these out, get rid of all the messy lines there. Okay. So let's go to position 6. I'm going to go back to my straight line tool. I go center of the earth, center of the moon, make the T. Again, I don't see anything above the crossbar. Cross that out. Now, when you're up here in the top portion of the cycle, when you're looking at it in this diagram, for example, this is the correct way you would see it. So in the sky, it's going to look that way. So whenever it's up here, it's fine. The one that tends to fool kids are these guys down here. When it's down in these lower phases, these lower portion, you always have to flip it in the sky. If they ever ask, they'll ask you sometimes on a Regents, they'll give you a blank circle and they'll say shade it in. For example, number 3, when a student would shade that, they'll shade the right side, but they're supposed to shade the left side. So be very careful with that. Anyway, back to 6. So I go center to center, draw the T. Notice I have a little bit of shadow now creeping in, right? I'm going in reverse. So I'm taking this waxing gibbous where the shadow was on the left. I'm flipping it the other way, mirror image. So now my shadow's on the right. I'm just past full moon, so I'm still in a gibbous phase, but now they don't call it the waxing gibbous. It's called the waning gibbous. I'm starting to head back toward the beginning of the cycle. I'm going in reverse. So there's my waning gibbous. Let's go to position 7. And again, I really like this T trick. I do think it works. I've been using it for a long, long time. So there's my T. Again, I always tell kids, cross out this part. Like you can do right on the test question. Just cross it out so you don't see it. It won't confuse you. And then I've got this port here. Again, I see the left side now illuminated. The right side's lit, opposite of 3. So I flip it around the other way. And that's my waning quarter. Or it's called the third quarter. Again, why the third? Well, if you notice, we're 3/4 of the way around our trip, right? The moon's made 3/4 of the way around, and that's why it's called the third quarter. Position 8. Center to center. Draw the T. Cross out this portion up here. And again, I see only a little tiny sliver as my little crescent, but it's on the left side. Remember over here, position 2 was on the right side. So I'm going to have a little crescent. But now it's on the left side. That's my waning crescent. And then I'm back to new moon, which was position 1. So if you remember that little capital T trick and just draw the T on the diagram, very easy. You'll see one of the assignments this week, I'll give you a bunch of questions where it'll say, you know, what does the moon look like at position 4? What does the moon look like at position 7? What does the moon look like at position 2? So if you just use that T trick idea, drawing those T's, that's going to help you with the correct phase. All right, and this is the final product, which we just had there. And this is showing the phases in order. So you've got your new moon, your waxing crescent. So the moon basically grows from right to left. So it's going that way. So you start with the illuminated portion growing. You got the waxing. You got the first quarter or waxing quarter. You've got the waxing gibbous. Everything growing from the right. And then the full. And then after the illuminated part grows from the right, then the shadow grows from the right. So everything kind of goes right to left. So then the shadow will start to come this way from the right. Waning gibbous, last quarter or third quarter, waning crescent. Another thing I like to see, and I like this, see where the last, that helps me. This is called waning quarter. This one I'm looking at, position 7. You can call it waning quarter. You can call it last quarter. You can call it third quarter. I like the word last. Why? Because that helps me remember what part of the moon is illuminated. Because notice what part's lit. The left side, right? So if you can remember that the left side, when you see the left side of the moon, left side of the moon, left side of the moon, you're at the last part of the cycle. And that's how I always remember it. I'll get into discussions with my wife. We'll look up at the sky driving and she'll say, oh, we must be heading toward a full moon. I'll say, well, let's look at the moon, honey. And I'll say, oh, look, the left side is illuminated. Oh, that means we're not at the beginning, we're at the end of the cycle. So whenever you see the left side, it's the end of the cycle, left last. That's how I remember that. It's a little trick. That's just an animation. I'll skip that. So there's your waxing moon. So waxing on, waning off, right? Waxing, getting bigger. So when we go from new moon to crescent to quarter, gibbous, full. Positions 1, 2, 3, 4, 5 is your waxing phases. Getting bigger. And waning is your past your full moon. So it's getting smaller, going in reverse. Waning, gibbous, again, last quarter, third quarter, and then waning crescent. Position 5, 6, 7, 8 is when it's waning. This week it won't be waning, it'll be snowing. Oh, there's my joke for the week. Actually, we're going to get a pretty good storm, so hope you're ready. Get your snowblowers ready, and at least from what I'm seeing online and reading and checking my news, my weather sources, it looks like a pretty good storm. I'm going to go out. I'm making this video on Sunday. I'm going to go out on a limb. It's coming in Wednesday. And Wednesday night should be pretty heavy. And then Thursday morning, you wake up, we could get a pretty good amount of snow. I don't know. I've seen everything from a foot to 18, 19, 20 inches of snow. So stay tuned on that one. I don't know amounts, but it should be a decent amount of snow. All right, tides. This number I did throw at you way back in the beginning of the year, so you do have to know that number. Tides happen about 12 and a half hours. So if you have a high tide on the Hudson River at, that's a horrible 8, but let's say it's 8 a.m. A high tide at 8 a.m. on the Hudson, the next high tide would be 8:30 p.m. And the way I do that, I add the half hour here, and then I just flip AM to PM. So I add a half hour first, and then, of course, 12 is just switching A to P, right? Or P to A. So let's say, they'll ask you down the regions. Let's say a high tide occurs at 9:30 p.m. That was a high tide. When is the next high tide? Add 30 minutes to that, so that makes it 10, right? And then switch the PM to the AM, so it's going to be 10 a.m. And then when would be the next high tide? 10:30 p.m. And then 11 a.m. And then 11:30 p.m. And you just keep flipping AM and PM and adding 30 minutes to it. So you have to know that. You also have to know what causes tides. Gravity. Same reason why we stay in orbit. Same reason how you keep your feet on the ground. Gravitational pull. So the Earth, the Moon, and the Sun are all aligned in some way to create the tides. The Sun has the greatest gravitational pull. The Moon is really the stronger force. Not that the Sun doesn't also affect the tides, but the Moon is going to affect the tides more. Why? Well, it's a lot closer, right? The Moon is only a couple 100,000 miles away. That's not much. Being as the Sun averages 93 million miles away. Big difference. So because the Moon is much, much closer, it's going to have more effect on our tides. Skip that. Let's go to this. So there are two special kinds of tides. They're called spring tides, and then this one's called, I'll skip page, come back, neap tide. N-E-A-P. Neap tide, spring tide. What's a spring tide? Spring tide doesn't have anything to do with the seasons. Doesn't mean, spring like the season spring. Spring meaning spring forward or springing up, right? Think of, Tigger in Winnie the Pooh, right? When he springs up. So a spring tide they're going to be much more extreme. I wrote that down on the bottom of the slide here. A spring tide happens twice a month. It happens at full moon and new moon. Why full moon and new moon? Everything is in a straight line. The sun, the earth, and the moon are all in a straight line. That creates extreme tides. You're going to have very, very, very strong high tides, and you're going to have very, very, very low tides because of that factor. And so let me go to this diagram. So when the sun, the earth, and the moon, this would be a full moon, right? When the moon's on the opposite side of the earth, sorry. Sun's over here, it goes sun, earth, moon. That's going to create very strong high tides and very low tides. The moon and the sun are really going to pull the water on one side of the earth, leaving very little water. Not very little. It's not like the fish are just laying there on dry land, but it lowers dramatically the amount of water on the other side to create extremely high tides, but then very, very low tides. So that's going to happen full moon and also, again, new moon, when everything's in a straight line. Okay, they call them spring tides twice. This is your worst case scenario for a storm. And I believe if you go back to 2012, when Superstorm Sandy hit, end of October 2012, it was during I believe it was a full moon. Don't quote me on that. I'd have to go back and look, or maybe somebody could look that up for me and just double check. Just Google what was the phase of the moon during Superstorm Sandy. I want to say it was a full moon. Or it could have been either full or new. It was one or the other. Everything was in the situation like that, which created so much more problems, especially for the tri-state area with all the flooding. Not that the storm itself didn't cause flooding, but when you have a hurricane or a storm like Sandy or something like that, the worst case scenario is they come in on, and the meteorologists, will say that. They'll say, this is a bad time to have a hurricane because it's astronomical high tide. And when they say that on the news, they're talking about it's astronomical high tide. What does that mean? It happens to be full moon or new moon. So that's going to enhance the tide. It's going to make it even worse. It's going to make the flooding even worse. So, and again, you can't do anything about it. You can't prevent when the hurricane hits. A hurricane hits when it wants to hit. It's not like you're going to tell a hurricane, well, just, hang out a couple more days, wait a week, and come back when the full moon is gone. Yeah, not going to happen. So when a full moon is happening and a hurricane hits or a storm, yeah, that's always not a good situation. Neap tide is actually the opposite. So instead of everything being in a line, what you end up with is the sun, the earth is here, let's say, put E. The moon is either at the first quarter or the third quarter, waning quarter or waxing quarter. That creates a right angle. So what does that mean? The moon wants to pull the water this way or this way. The sun wants to pull the ocean this way. So it's kind of offset. Moon's going this way with the water or this way. Sun's pulling it this way. Creates an offset situation. It's like tug of war. I was related to that. Let's say I had two teams that were pretty evenly matched, and the person in the middle, the referee's got the little red rope there and says ready, set, go, and the two teams start pulling on the tug of war, but the red rope in the middle doesn't really move. Both teams are pretty even, and you could sit there for quite a while, just the rope hardly moving. That's kind of the same idea. Think of tug of war. So it's a tug of war between the sun and the moon. The moon is pulling water this way, sun's pulling water this way. They both offset each other. Your tides are not going to be as extreme. Moderate. Moderate means not as high and not as low. So the low tides aren't that low and the high tides aren't that high. This would be your best case scenario. So I guess if a hurricane's going to hit or a nor'easter's going to hit, you want it to hopefully come in on one of your quarter moons, either the first quarter or the third quarter, last quarter. That's always your best case scenario for a storm. And this picture shows that. So again, the moon is going this way with the water, and the sun is pulling this way with the water, and they offset each other. So they're called neap tides, N-E-A-P, neap. And this just shows all of them. So your extreme tides, again, very high and very low, are your new moon and full moon. Everything's in a straight line, sun, earth, moon. And then your quarter moons are your neap tides, pulling water in opposite directions. All right, one more thing to cover, and that's your lunar eclipses. So the word eclipse means to block, So a luna, meaning moon, you're blocking out the moon. This would be, and this was on that last lab we did, solar system lab. You had to put an L to show where the Earth is and for a lunar eclipse, and an S to show where it is during a solar. So in a lunar eclipse, sunlight hits the Earth. We are 4 times larger than the moon. So because we're a much bigger object, we make a bigger shadow, right? Bigger object, bigger shadow. We can block out the moon easier than the moon can block us. And so lunar eclipses happen more frequently. I'll show you a list in a minute. So the sun hits the Earth. The Earth is then going to go toward the moon and create a shadow. And so that darkens out the moon. They call that a lunar eclipse, which you'll notice this is going to happen what phase? Well, if I draw the T, right, you would see the illuminated part. This is only going to happen during full moons. So when you have full moons is when you could have a lunar eclipse. You're not going to have it every time, because if you remember back at the beginning of the video, the moon is at a 5-degree tilt, orbital plane, and so everything is not in a straight line every month. But some months you will have full moons and lunar eclipses. Now there's 2 different types of lunar eclipses. If the moon happens to be directly behind the darkest part of Earth's shadow, this part in here, it's called the umbra. That's going to create a total lunar eclipse where the entire moon will get shadowed out, darkened out. If the moon is kind of off to the side, might be a little bit over here, a little bit over here, maybe just coming out of full moons, like a day after full moon or a day before full moon, which could happen. They call that the penumbra. And so those are actually called penumbral eclipses or partial. I always remember penumbral means partial. You're not going to block, our shadow's not going to block the entire moon. It's going to be like, maybe half, 3/4. So you'll have a partial lunar eclipse. So it depends on where the moon is. If it's directly behind in the dark shadow, it's umbra. If it's off to the side, the moon a little bit here or here, it's penumbra, which would create the middle one's total, the sides are partial. And then a solar eclipse, again, the word eclipse means to block. So now we're blocking out the sun. This is going to happen. You have a bright sunny day, and notice where the moon is now, or the Earth. The Earth's on the other side. This is going to happen during a new moon. So opposite, right? If you have you can have solar eclipses, you can have lunar eclipses during a full moon. You can have solar eclipses only during a new moon. The moon has to be between the Earth and the sun. And so all of a sudden you're looking at the sun on a bright sunny day, and all of a sudden the moon crosses in front of our path of the sun and blocks out our view of the sun. And that's a solar eclipse, blocks the sun. Not going to happen as often. Why? Again, the moon is only a quarter of the size, right? We're 4 times bigger. So if it's only a quarter of the size of the Earth, right? Quarter of the size makes a quarter of the shadow. Makes a very, very tiny, tiny shadow. You're not going to block the entire Earth that way. Not going to happen. Total eclipse, solar eclipses, or even partial solar eclipses might not happen all over. Lunar eclipses tend to cover most continents. We'll see them when there are lunar eclipses. Solars might only be 1 or 2 continents at a time. And I have a list here. Let me get to that list. Well, here's, so for us, we had a solar eclipse. I don't know if you recall. This was 3 years ago now. August 21st, 2017. That was our first solar eclipse in the U.S. since July of 91. So the one before that was 1991, right? We waited, 20-something years, 26 years till the next total eclipse. And now the next one actually won't have to wait that many years. So we go from 17 to 24. So now we're heading into 21. So we got about a little more than 3 years, right? April 8th. Hopefully it's a sunny day. April, you never know, because it's always rainy in April. Tends to be, right? April showers. So let's keep our fingers crossed. April 8th, 2024 will be a nice, bright, sunny day. Again, I think I mentioned that in class. You guys will be seniors, right? You freshmen. And so that'll be your senior year, right around the time of April break. You could always stop by Mr. Rocco's classroom. If we're in school. I have these solar glasses, and you can come and we can actually check out the eclipse. That'll be kind of cool. So let's see if we're in school on the 8th of April and it's a sunny day and you want to stop by my classroom, please do, because we can all take a look at the eclipse. And these are just a list of some of the lunar eclipses that are lunar, yeah. So there's usually 2 every year. Well, you can see on average. So we have 2 next year, 2021. May 26th, that'll be right around Memorial Day. And if it says Americas, see what I did? I highlighted them in yellow. So Americas meaning North America, South America. So that would include us. So we have a total, it tells you, total eclipse. That'll be May of 2021. So that's coming up before this school year ends. That'll be a good one. There'll be a partial lunar eclipse November of next year. Let's see. 2022, there's 2. These are both for Americas. May 16th, that'll be another total eclipse. And November 8th of 2022, that'll be another total eclipse. So we have 2 in 2022. Like I said, about 2 every year. Here's 2 in 2023, and unfortunately, neither one of those are us. East America's, actually, no, East America would be the East Coast, so we might see this one, the October 2023. We have 2 in 2024, March 25th and September 18th. Both of these are partial, penumbral partial. We have 2 in 2025, March and September. The September one, no. But we'll see the March one, March 14th, 2025. That's a total. We have 2 in 2026, March and August. This one's total. This one's partial. And then we have, let's see, February of 27. That's partial. And January of 28. That's partial. So that's a list, and you can keep going. I just cut and paste a small chunk, but that's going for the next 7-8 years. And then if we go to our solar eclipses, actually, let's see, today is, I'm making this video, is 13th. Tomorrow, first day of the week, December 14th, Monday, is a solar eclipse. It's a total solar eclipse. So it's going to happen tomorrow. Might be on the news. They might cover it for 2 seconds. Who knows? But it won't be us. It's the Pacific, South America, and Antarctica. So you're looking at the Pacific Ocean, Chile, Argentina, maybe the South Atlantic Ocean. Okay, so your South America, South Atlantic, places like that, Chile, Argentina. Not for us. So if you know any friends or relatives or anybody down in Chile, Argentina tomorrow, they will get to see a total eclipse. Again, ours is April of 2024. Total eclipse. This just gives you how long it'll be eclipsed. So you're looking at right here 4 minutes and 28 seconds. So that's pretty decent. 4.5 minutes. So there'll be total darkness for 4.5 minutes, which is kind of cool. And I think that's it. All right, I will post this one on Canvas. It ran a little long. I apologize. It's going to be one other video this week on the stars and it's called stellar evolution, looking at the life cycle of a star. And then you've got your assignments, which will be also on Canvas. And don't forget about the 5-week period ends this Friday. So it's very important, critical that you get any missing work in ASAP. Okay, I will talk to you soon.